Shall we start? Ready to go. Okay, hi class. I'm very glad to be here to talk to you about plate tectonics. Probably some of you know that I'm a Morrison dad. I have two boys in Morrison, Aaron in the 7th grade and Eden in the 5th grade. You probably know them. However, the reason why I'm here is not because I'm a dad. It's because my professional training. I'm trained as a coastal oceanographer. I got my PhD from the State University of New York at Stony Brook. I also received 2 postdoctoral trainings at Woods Hole Oceanographic Institution and the Harbor Branch Oceanographic Institution. I came back to Taiwan in 1993. And so basically, I'm a geological oceanographer or process-oriented coastal geologist. However, as a scientist, I also believe in God. As a scientist, when I do research, I'm mindful that God created everything in which I do research. And God is the original cause for all the effects that I'm researching on. Just imagine if God did not create an orderly universe, there, by observing the effect, you can trace back the source, then that would be no science. As a very well-known Christian theologian and thinker, Francis Schaeffer, said very well, God has made a cause and effective universe. Therefore, we, the scientists, and you, can find out something about the cause from the effect, living with the concept that the world was created by a reasonable God. Scientists, people like me, could move with confidence, expecting to be able to find out about the world by observation and experimentation. If there's no connection, if everything happened randomly, there's no use to do experimentation or to make observations because you won't find out about anything. So, having that said, what are we going to learn today? There are several things I'd like to share with you. The Earth's principal features, the principles of plate tectonic theory. What are the evidences to support the theory? How does plate tectonics work? How does plate tectonics affect the seafloor morphology around Taiwan? Because that's where we live. How does the plate tectonics affect our life on the island of Taiwan and elsewhere? Okay, imagine there's a super water pump in the outer space, and it pumps out all the seawater in the oceans, and that's what you will see on the surface of the Earth. Okay, so the yellow parts are where the land is, and the blue part are the ocean floor, where the water was. Now, by looking at this, can you describe what do you see? Just describe the surface. Yes? Cracks. Okay. You see the cracks. Anyone else? Yes?
Bumpy.
Yes, bumpy, huh? Not smooth at all. Okay, how do you describe this bumpiness and cracks? There's one word. I'm looking for one word. How do you describe? Not smooth, not flat.
Rough.
Sorry?
Rough.
Rough. Getting close. One last chance. Rugged. Does anybody know the word rugged? Yes. You can see that the seafloor actually, they are mountains and valleys, actually long mountain ranges. So, rugged ocean floor, okay, not smooth at all. So that is the principal feature. in addition to the mountains we see on land, the Himalayas, the Jade Mountain, the Alps, the American Sierras. Okay, now let's talk about the plate tectonics. Okay. Plate tectonic theory is a very important theory in the field of earth science or geology. It has the same stature as the theory of evolution in biological sciences, because now we almost interpret everything, every geological processes in terms of plate tectonics. But there's a difference. The theory of plate tectonics has validity, and the theory of evolution doesn't. Okay, when you get to 9th grade, you get to debate my students from Zhongshan University, and you get to learn more about that. Okay, so basically what it describes is that the planet that we live is constantly shifting. It's not steady at all, because there are plates, just like jigsaw puzzles. So they're constantly changing places. Okay, and that's why at some places there are volcanoes, there are earthquakes. It's all because of this moving, shifting earth, shifting plates. Now, I'm going to tell you a story first about this German guy called Alfred Wegener. Wegener was a very smart guy. Wegener, like Charles Darwin, he made a very important observation. He noticed that on both sides, the shorelines of both sides of the Atlantic Ocean, the African continent and the North and South American continent, seems that they can fit together. And also, he collected some very rudimentary evidence, and he came up with a theory of a continental drift. So he wrote a book in German, because he was a German, called The Origin of Continents and Oceans. Does that remind you the name of another book? By Darwin, The Origin of Species. Okay. They all start with the word, the origin, because they're all trying to explain about the first cause of things. Okay. Now, Wegener died with his rudimentary evidence. He didn't have access to later evidence that would fully support his crazy idea. How can continents drift? How can they move? Okay, isn't that crazy? Right? Okay, hold your horses. It's not crazy. Now, this is what Wegener saw. Would you think that it's like two pieces of a puzzle? Would you? Do you think they would fit? Who would think that they would fit? Who doesn't think that would fit? You are very skeptical, huh? Okay, now, maybe assignment for you. Go cut up a map of the continents. Try to piece them together. Okay, actually, Wegener has already done that. That's what, see? He cut up the continents and tried to piece them, and actually he found there's some old ancient rocks and some things that would fit, So that supports his basic idea of continental drift. And you can do that too if you don't believe. I encourage you to do that. Okay, so in his theory, okay, these are very long years, okay, 225 million years, okay, 225 multiplied 10 to the 6th order, very, very old, okay. So this is the content of theory continental drift. So in 225 years ago, there is a big land piece called Pangaea. And then when the time went on, it split, and all the pieces began to move around. Finally, they moved to their present location. Okay, now there even a crazy thing here. This is a result of scientific research. Okay, it started out at 150 million years ago. Okay, and see at this time, Pangaea, that one big ancient paleo continent, has already broken up into several pieces. Okay, sit tight. Whoa, play music chair. Okay, this is, do you recognize this now? That's the present, world. Okay, now what this is, scientists collect evidence. These are all the locations where evidence came from. Based on this evidence, they reconstructed step by step, going back. So imagine you have a time machine. Okay, you go back. Have you seen the slow movie, playing back? Like, accidents, traffic accidents? Okay. Yeah. So go back to where the evidence lead to. That's 150 million years ago. That was like this. So now let's play it frame by frame. Let's examine some of the things. Okay. So as according to this is evidence. This is not theory. Okay. This is reconstruction, just like CSI. Who has watched CSI? Actually, CSI, yes. What we do is really CSI work. We collect evidence and we reconstruct the crime theme. In this case, it's the past world history, planet history. So now, look. In 130 million years ago, there was no Atlantic Ocean. There was this ancient big Pacific Ocean, and or you call the Paleo-Pacific Ocean, and then the Paleo-Indian Ocean. Okay, and Antarctica is down there. The Paleo-Australian continent is here. So then Atlantic was born. Okay, so comparing to the Pacific Ocean, the Atlantic Ocean is really young. Okay, as we're getting close, okay, pay attention to this location and this location. This is a Paleo-Indian subcontinent. This is where the Alps is. Okay, Indian continent is bang, went into the Eurasian continent, and then the land is squeezed here. So here you have Europe's highest mountain, that's the Alps, and you have the what you call the ceiling of the world, that's the Himalayas, because the ramming, the collision of Indian subcontinent with the Asian continent that squeezed and lifted up the Himalaya mountains. So this is basically the essence of continental drift theory. Okay. That's the evidence or recreation of that. Okay. Now, what we saw is a recreation. So just what exactly are the evidences? First one is somebody's pointed out that on the seafloor there are long mountain ranges, okay, that could be as high as 4,500 meters above the seafloor, okay, and as long as 5,000, 50,000 kilometers around the globe. These are huge mountain ranges. You can see that all around, okay, in the center of the Atlantics and in the Pacific Ocean and Antarctica. And actually, on both sides of the ridges, there is a science called paleomagnetism. That means when magma came to the Earth's surface, the minerals, iron-rich minerals in the magma, would, before the magma cools and solidifies, these minerals, like tiny, tiny compasses, they would align themselves with the world's magnetic field at that time. Then they are frozen. Okay, but the world magnetic field changes, reverses. Sometimes North Pole is in the south and South Pole in the north, vice versa. And also, they lock in. So they lock in the location of the pole, the orientation of the pole. In general, it can be defined as a positive or negative. So you have alternate positive and a negative polarity. Just like in the computer, it's binary, right? It's either 1 or 0, either 1 or 0. So that's the polarity, magnetic polarity. So as magma comes and cools and moves away, that creates this big paleomagnetic evidence on the seafloor. And that looks like this, the bands. Okay, what does that remind you of? When you go to a store, when you buy something, the clerk would scan. Chirp. What does the clerk scan?
Barcode.
Yes, barcode. We have barcodes on the seafloor, gigantic barcodes. Okay, so scientists develop ways like a gigantic scanner to scan these barcodes. What do they tell us? It tells us about the Earth's history, about the location of the poles, the polarity, and age. So this is an example of British Columbia and North Washington. And also, it tells us that if we trace the same location, the orientation of polarity from different places for the same time, we can trace back to the same origin. That's the same North Pole, which tells us that their positions must have changed through time. Okay. So, in the development of the theory of continental drift, rugged Earth, okay, and ruggedness youth of the seafloor, and then confirmation of repeated reversals. Okay, that's the magnetic bands, and then there's emergence of the seafloor spreading hypothesis. Because in order for the drifting continents to work, the seafloor has to expand, spread, so that they are moving apart, as you saw in that animation. And also, from the precise documentation of volcanic activities and earthquakes, we can pinpoint the boundary of plates. Here, let's not get ahead of us. Along the mid-Atlantic ridges, you all see that the ages of islands are getting older as they move away from the ridges. That means farther away, they're older, meaning that they came up earlier. Okay, the closer to the ridge, the age of the seafloor are younger. Now, if we map out all the age according to paleomagnetism, and the darker part is where the location of ages. You can see that the closer to the ridge, the younger. These are millions of years. Okay, 2 million years, 0 to 2, and 135 to 190 million of years. So the farther outside, it's older because the seafloor is spreading. Another evidence is location of hotspots. Hotspots are located in the deeper part of the mantle. So at the location of the hotspot, there are hot magma that coming up and to form volcanoes. Okay. But the moving plate, so they would penetrate the plate and to form volcanoes. As the plate moves away, the hotspot remained at the same location, so they would create new volcanoes. After a while, they would create a series of volcanoes in the direction in which the plate is moving. So by tracking at the orientation where how these volcanic islands lined up in the Pacific Ocean, we'll see that here there are several hotspots. One is the most famous in the world, Hawaii. Who has been to Hawaii? Have you seen volcanoes? Okay, good. Well, hopefully someday you will. You see that if you draw the lines, if you connect all the dots of all the islands, you see that they are in a parallel direction. They're all parallel to each other. That tells you that the plate is moving in that direction. Okay, so that's one direct evidence because the hotspots don't move, but the plate does. Just like if you hold a candle, okay, underneath a plate. Don't do that at home. You see the smoke would make would char whatever that thing, and then you move away slowly. You will see eventually the charred part will form a line. Okay, that's exactly what this happened on the ocean floor. So volcanoes in the islands to show that there are hotspots deeper down in the mantle. There are also other evidence. Now we reconstructed. So these shields are very old geological formations, also mountain ranges that Wagner did not have access to. Okay, so we have some new evidence to support the theory of continental drift. And then people come up with the seafloor spreading theory. Okay, now all the two things gradually emerged into a theory of plate tectonics. And how does plate tectonic how does the plate tectonics work? Okay, basically, the plate is just a thin layer of crust. Okay, that's part of the lithosphere. And underneath, there's something called asthenosphere, which is part of the mantle. And within the mantle, within the asthenosphere, there are conveyor cells. Okay, this is similar to what you do in a chemistry lab. You use a flame and put it under a burner under a flask with water, and you will create a circulation in a flask. Exactly, that's what it's like in the Earth mantle. So they are circulation cells at the place where the circulation diverges, and that's the location of oceanic ridge, because that's where the magma is coming out to the seafloor. And then they will move this way, like a conveyor belt. This conveyor belt movement drags the plate away from the spreading center. And if so, new material is created at the spreading center. But if it keeps going that and the new material does not get recycled, the Earth would get bigger and bigger, just like as if you blow a balloon, a ball. The balloon keeps expanding, right? So in order for the Earth to keep a constant size, this plate, new material, as they move away, they have to go somewhere else. And that's where the changes are. When the two plates collide, and one will go under, this is called subduction, or one plate will subduct under the other. As they go under, going back down into the external sphere, they get recycled. God, who thought about the recycling idea? God did, with the material he created to make the plates. So there's new material coming up. As they move away, they get older and older, and then they go down in the trench, go back into the deeper part, and then get recycled. So in that sense, the size of the planet Earth remains the same. Okay. Now, how do we determine the boundary of a plate, or how many plates are there? So basically, by pinpointing location of volcanic activities and the earthquake activities. If we map the occurrence of all those on the map, this is what we would come up with, all the dots. Okay, if you connect all the dots, you would delineate the boundary of different plates. Okay, we're here, Taiwan. Taiwan is actually in a very precarious location I will get to later. So in this neighborhood, there is a large plates are the Eurasian plate here and here, also Pacific plate. And in between the Eurasian plate and Pacific plate, there is a smaller Philippine plate. There's Australian plate. The North America is on the North American plate, and South American plate, and African plate. So these are the major plates, just like major puzzles. And the plates are also moving. As we said, this is a shifting planet. Okay. The directions shows where the plates are moving. There are ways to determine the rate of movement. Many scientists in different countries, they use GPS, very high precision GPS. They can measure the rate and direction of continental movement. And also if there is lifting, crumbling up because collision, and also subsidence. So we are not where we put our feet on, the land is moving. It's not stable because the plates are constantly moving. Actually, in hundreds of millions years, LA will come over here. Okay, so if you can wait that long, so here, the plate boundaries. We'll get to that. But basically, the oceanic ridges delineate some type of a plate boundary. Also, the trenches. Something I want to share with you is this term called the ring of fire. Have you heard? Anybody? Ring of fire. Okay. Yes. That's where we live. Okay, along the ring of fire. So we're like circus animals. Tigers, lions jumping over the circle of fire. Why is it called a ring of fire? Well, that's exactly, see, from along South America, North America, Aleutian Islands, Japan Islands, and Pacific Islands, and Taiwan, Philippines. Okay, because this actually it's a half ring, not a whole ring. But okay, why there are fires? Because when one plate subducts the other, the friction would create magma. Magma would come up to create that would make volcanoes, and also the colliding plates would cause the Earth to shake and create earthquakes. I will get to that later. Now, basically, let's say this is a global view of the conveyor belt. So there's spreading center. You come up, and there's you subduct. Okay, there's always where new crust materials is created, and there's place that the old crust material is recycled. So the entire Earth, there are spreading centers, there are subduction zones all over the entire Earth. Now, we just saw their major plates. The boundary, okay, where two plates are next to each other are called the plate boundaries. There are 4 different types of plate boundaries. Okay, there are divergent boundaries, convergent boundaries, transform boundaries, and the plate boundary zones. Okay. Basically, divergent boundary is where two plates move apart. Okay, because the conveyor belt moves in the opposite direction. So there's that as they move away, there's a crack, magma comes up, and then cools and forms a new material. So that is called the divergent boundary. And then when the two boundaries come together, that's called the convergent boundary. That's where the subduction takes place. One boundary dives another boundary, and this surface is called Benioff zone. That's where a lot of deep earthquakes occur because the friction, the stress that one plate moves against the other, and also the moving creates a lot of heat that melt the old material, that form magma chambers. They come up through weak points. They form volcanoes if they found weakness to come out. So there are frequent volcanic explosions. Actually, the nearest was 2 years ago, 3 years ago in the Philippines. There was a volcanic volcanic eruption. So, and another type, transform boundary, is where the movement of two boundaries, the movement tears a boundary apart. The fourth type is not clear. That happens in the alpine region that I'm not going to talk about. So, mid-ocean ridges are very good example of divergent boundaries because that's where the two plates move apart from each other. Okay, that's another picture at the divergent boundaries. Your magma coming up, plates move away, and also in the Central Valley, because of the tension that form cracks, the center would form a central valley. Along the side of the oceanic ridges, remember there are huge mountains. Along the cracks, they are hot water. There are hot springs would seeping out. Okay, just like hot springs on land in Taiwan, but the temperature is very hot. Okay, can melt metal, and also along these cracks, you will see these black smokes. As the water, hot water is being ejected, they carry a lot of mineral-rich material. Okay, that of the element that form the mantle of the earth, and all these white things are animals, organisms that they use the nutrients contained in these hydrothermal vents. And this is called the chemosynthesis, as opposed to photosynthesis. Does anybody not understand what photosynthesis is? Good. You know, you eat green vegetables, you go out, get sun, and you create energy yourself. So that's photosynthesis. Okay, I'm just kidding. The plant, okay, absorbs the sunlight and creates food. That's photosynthesis. But in thousands meters deep in the deep ocean, there's no light, so there cannot be photosynthesis. So the basic producers down on the lowest trophic level, they would use nutrient from this hydrothermal vent to create food for themselves. Okay, so it's a totally different ecosystem, and you would think that those ecosystems are oligotrophic. That means very lack of nutrition. Actually, it's not. You can see how fat those tube worms are. Okay, looks very delicious, huh? Bigger than the legs of the king crabs. Okay, so, and also see the clams, huge clams. Okay, it's a totally different world down there as a result of plate tectonics. Okay, now one particular area on this planet is Rift Valley in East Africa. This is where you can actually witness how continents get split apart, and how new crust is being formed, and how a young ocean is being formed. You know, Red Sea and the Gulf Aden. Okay, these were the ancient spreading centers. Actually, there along this, there is the Rift Valley of East Africa. The Horn of Africa is moving away, actually, from the African continent as I speak right now. And so eventually, Red Sea and Gulf of Aden will encroach on the Rift Valley. This will become a new ocean, and eventually Horn of Africa will move away. So that's what it happens, and it has a lot of evidence to support that. For example, volcanic activities, just like the spreading centers on the seafloor, the magma comes up, and the hydrothermal events, and there are several volcanoes and earthquakes that all point to that, and the splitting of the forming of a new continent and a new ocean. And this place is called Triple Junction, because that's where the two, the spreading center, the two spreading centers join. Okay. Now here's just a picture of oceanic and continental convergence. This is actually happens. This is located in South America, where Chile. Not long ago, there was a huge earthquake in Chile. I don't know if you remember. It's because of this kind of collision. Okay, continent and ocean convergence. That's where we are. Okay, Taiwan has a lot of earthquakes, and so does Japan, our neighboring countries. It's because where we are on generally is on the oceanic plate, and when the oceanic plate subducts into continental plate, so that creates a volcanic island chain. That's basically what made the ring of fire. The third type of collision is continental collision. That's Himalaya, where the Himalayan plateau was formed. You saw that animation when the Indian subcontinent came up and ran into the Asian continent, and that's made this kind of a convergence collision. And a very special thing is it's called transform boundary. Who has been to California? There's a very, very peculiar landform, okay, San Andreas Fault. Have anybody seen that? It is a special boundary, okay, that separates the two plates and links the two oceanic ridges. Okay, so there are a lot of evidence and also the effect of plate tectonics. Here, the plate tectonic theory in a nutshell. Okay, now who can name some of the numbers? Can you name some of the numbers? Okay, number 7 is what and what? Number 12, what and what? Who wants to volunteer? Okay.
Number 8 is subduction zone.
Very good. 8 and 9, subduction zone. Very good. Anyone else? Yes.
Number 6 is divergent.
Yes, excellent. Divergent boundary. Anyone else? Okay. Yes. Yeah, external sphere. Okay, let's not waste time. So here the keys are down below. Okay, basically you have a part of the conveyor belt, the heat source that comes up, and the conveyor moves in one direction and in this direction, and there's magma coming up, forming the oceanic ridges, and then the plate is pulled away, and as it pulled away, it becomes older. So and then it subducts underneath, and the friction would cause heat that would cause earthquakes, create magma that would come up in the weakness, the form of volcanic. Sometimes they erupt, and then the old crust material is being recycled. Okay, basically that's in a nutshell. And here is a divergent boundary, collision boundary, spreading center, subduction zone. Okay, so if you don't remember anything what I said, just remember this. Okay, plate tectonics in a nutshell. Okay. So you say, how does it relate to me? Okay, seems that living on plate boundaries, especially in collision zones, the ring of fire, you get nothing but the negatives. You get, horrifying earthquakes, sometimes kill people. Volcanic eruptions also kill people that affected the environment. Okay, but also, okay, the positive side is geothermal energy. Okay, I don't know if anybody's been to Iceland. Okay, Iceland is a country that's full of geothermal energy. Okay, because of plate tectonics. Okay, hot springs that can use to drive turbines, to provide energy to heat houses, to generate electricity, and also minerals, because there are a lot of rich minerals that associated with magmas and fertile soil. Hawaii, for example, have you seen the soil of Hawaii Islands? Right, pitch black, very fertile. Okay, that grow, beautiful fruits and vegetables, and also beautiful sceneries. When you go to Hawaii, you see volcanoes. You go to Taiwan, the Central Mountain Range. You go to Torogo Gorge. You go on the Suhua Highway. You go to Italy. You go to the Alps. You go to the American Rockies. These are all result of plate tectonics collision. Beautiful sceneries. Okay. So Now, how does that affect Taiwan? Taiwan is a very special place because this is actually a crowded place for tectonic plates. There are actually, two plates. Okay. The Philippine plate here collides into a Eurasia plate, but in a very peculiar way, interlocking way. In southern Taiwan, the Eurasia plate subducts under the Philippine plate. In northern Taiwan, the Philippine plate subducts under Eurasia plate. So you have this three-dimensional interlocking thing. That made Taiwan very rugged and very prone earthquakes. Okay. If you go to the East Rift Valley in eastern Taiwan, you'll actually see that's the Rift Valley. On the eastern side is part of the Pacific, the Philippine plate. On the western side is the older Central Mountain Ridge is the Eurasia plate. Okay, and these are how the Taiwan was formed. Basically, the collision lifted the Taiwan up and formed what Taiwan is today. Okay, so if you take a cross section along the center of Taiwan, that's what you would see: different ages of rocks and different deformations. Here's the coastal range. That's the Rift Valley, Pacific Ocean, Taiwan Strait. Okay, and the highest mountain is the highest peak in Southeast Asia, Yushan. Okay, Mount Jade. Has anybody been up there? Really? Great. Me too. Okay. 3997 meters above sea level. Okay. So that's why that gives the rugged seafloor morphology and the island of Taiwan just very complex. Okay. How does plate tectonics affect our life on the island elsewhere? Rugged. Okay. Okay. These are the elevations above sea level. There are over 200 peaks along the central range that are higher than 3,000 meters. That's 10,000 feet. Okay, in very short distance, more than 200 peaks. Very rugged, very steep mountain slopes, and also many earthquakes. These are the epicenters of earthquakes. The blue ones are deeper ones. You can see that they are all along the subducting plate boundaries. This is where the Philippine plate subducts under Eurasia plate. Here, Eurasia plate subducts under the Philippine plate. Okay, and the plate movement also cause deformation that are called faults, thrust faults or normal faults. Remember, 2000, I don't know when, there was a GG earthquake in central Taiwan. It's because of a normal fault. See, this displacement is along the fault line. Actually, and the two blocks snapped, and this is actually what happened in Tokyo, at the Fukuoka tsunami. Is at the what happened last year on March the 11th was that offshore Japan, near the trenches, there was a snap of two plates. Okay. This is a depiction of the snap. If this block rises up, that would create a tsunami moving in that direction. If it happens in this way, the tsunami would move in the other direction. Tsunami wave is a long wave comparing to wind waves. That's why you saw on TV, the water just keeps coming because it's long wave, and as it moves inshore, it becomes shoaling takes place, so it actually rises up higher and higher. Okay, so going back to my original, but all this is really a result of creation. we are very limited as a scientist, as anybody that in the face of God's mighty power, we're limited. And we also were witness to the beauty of plate tectonics, what plate tectonics created. This is the eastern coast of Taiwan. So by faith, we understand that the universe was formed by as God's command, so that what is seen was not made out of what was visible. Okay, I'm going to stop here. Yeah, done. And fini.